Hello, my name is Jose Garcia Ruiz, and my question is, how can you define the velocity of an object that is in constant motion at a specific time? So for this question, we're going to use something that is known as instantaneous velocity, which I will show you later. So the instantaneous velocity means the velocity of an object at a specific moment in time. This is what instantaneous velocity stands for. So for this, we're going to use an equation. S equals negative 1.5 t squared plus 10 t plus 4, in which S represents displacement and t represents time. In order to solve this equation, or actually one of the questions it's asking for is, what is the velocity at 5 seconds? So to do this equation, we first need to take the equation's derivative. The derivative of an equation is just a different equation that tells you its slope that is given at a specific moment in time. So for example, right here, start by going through the t side of the equation from left to right. So for example here, every time you reach a t, subtract 1 from this exponent, so it would be here, and multiply the entire term by the original exponent. So it would be 2 minus 1.5 t exponent 2 minus 1 plus 1 10t exponent 1 minus 1 plus 0 times 4t exponent 0, which this results, multiplying these two values gives you negative 3 t1 from the exponent value over here plus 10t 0, since this cancels out and basically becomes nothing. The t0 cancels out, it equals 1. You multiply that times the 10, which gives you the original equation of negative 3t plus 10. In order to find the velocity at 5 seconds, we just simply replace the t with 5. So the equation for this, now that we found this, it would be ds over dt equals negative 3t plus 10. This is the equation to find the instantaneous velocity of this equation over here. So now we're going to use the 5, replacing it with t. So ds over dt equals negative 3 times 5 plus 10, giving you a number of negative 15 plus 10, resulting in the answer of negative 5 meters per second. That is the answer to this question here. Now we're going to use the same thing and apply it to a different equation. S equals 5t3 plus 3t squared minus 2t plus 9. This actually can also require the same method with, yet again, the first step, taking the equation's derivative. So it would be S equals 5t, 3 minus 1, made a mistake there, 3 minus 1, because that's the exponent of 3 over here, minus 2 times 3t, 2 minus 1, plus 1 2t, 1 minus 1, plus 0, 9t, 0 minus 1. Which all this together gives you just 0. It would this entire equation right here results in 15t squared minus 6t1 plus 2t 0. This cancels out, making it 1. Multiplying this by 2, what's the rest of the equation gives you 15t squared minus 6t plus 2. This equation is actually asking what is the velocity at 3 seconds. So we're going to do the same thing. We're going to replace the t with 3. So it would be s equals 15 3 squared minus 6 3 plus 2. 3 to the power of 2 is 9, so 15 times 9 minus 18 from this plus 2 can give you this is going to be an actual whole number. Now opening the calculator right here, it would be 15 times 9 minus 18 plus 2. Oops, actually that was the wrong thing I did. 15 times 9 minus 18 plus 2. This gives you the total, the instantaneous velocity at 3 seconds, 119 meters per second. It can be meters or feet, anything. For this equation, it was actually asking for a velocity at 3 seconds in meters. So the answer was 119 meters per second. And that is the way to find instantaneous velocity with this equation. So my thoughts in this problem was actually, to be honest, it wasn't really hard. It was just basically taking the equation's derivative. It wasn't actually really hard to do, actually. But the reason why I chose this, I thought it was something hard because this was actually required with calculus and physics. And it wasn't really hard. I was just taking my time, actually realizing life is not hard. It's actually really easy. And yeah, I hope you enjoyed my video with this. And that's it.